Good time of day to everyone, and I would like to thank the organizers for providing me this opportunity to give my talk today, which is unfortunately in asynchronous, not in recorded format, because I couldn't come to US this year. Also, I apologize for somewhat extending the subject of my talk. All this is because of Russian full-scale invasion into our country, which forced us to stop all the operations for some time, and then only now we are resuming the internal research projects. So we couldn't obtain all the results that were planned for the initial title in time. Therefore, I will present you all the results on the chemistry of diazoalkane 2 that we have at the moment. They are, in fact, reflected in this graphical abstract that was provided to the abstract of this talk. And then shall switch to the chemistry of saturated dimethyl PO substituted nitrogen heterocycles that we have been synthesizing in our group also. So why we have become interested in this topic? Until recently, phosphine oxides were considered as merely as annoying byproducts in organic synthesis reactions such as Me2P or Apple or Wittig reaction. They also formed upon oxidation of phosphines in their synthesis, which is also an unwanted process. In medicinal chemistry, they were typically overlooked and sorted out by MedChem filters until recently. The game changer in this situation became discovery and development of brigatinib, an anti-cancer agent which was introduced into the market in 2018 by Pharmaceuticals. Apart from this compound, I must say that there are much more, and one of the first examples was registered as early as in 1970s. This is a sedative drug, fosazepam. Therefore, these compounds indeed might have been interesting for medicinal chemistry. So why they are interesting to medicinal chemistry? Phosphine oxide moiety is a very polar group, which is a strong H-bond acceptor. This substituent increases compounds' aqueous solubility and hydrophilicity, improves its microsomal stability since CP bonds are quite stable upon metabolytic process towards metabolytic transformations. Also, it modifies the compounds pKa. It has been considered as an isoster for sulfoxides, sulfones, sulfonamides, carboxamides, and some other groups. It should be noted that at the moment, the PO-dimethyl substituted building blocks are quite rare. Very recently, another group from Inamine, advised by Pavlo Mikhailuk, published a paper in JOC describing palladium-catalyzed CP coupling of aryl and heteryl halides with dimethyl phosphine oxide. And this reaction provided an access to a huge number of heteroaromatic and aromatic building blocks containing the dimethyl phosphine oxide moiety. Another important transformation in this field is Kabachnik-Fields reaction that can be also considered as phosphomanic reaction, which is a reaction of aldehyde, primary or secondary amine or ammonia, and dimethyl phosphine oxide, providing alpha amino substituted phosphine oxides. This reaction was well documented in the literature, typically for the preparation of acyclic aminophosphine oxides. Therefore, there is much to do in this area in terms of synthesis. For example, saturated heterocyclic building blocks have been largely omitted. Also, some efforts can be put to the design and the synthesis of small reagents having the pivot-methyl moiety, for example, diazolcan. And I shall start with the second part, with the second point. In fact, we have some experience with diazolcanes at enamine, and we have, first of all, we have applied the standard additions for the electron pair, for the synthesis of electron pair diazolcane. We have obtained compound 1, which is can be prepared in one step in a large scale, and subjected it into the reaction with aqueous sodium nitrite. Unfortunately, no product was obtained under these conditions. Instead, hydroxy derivative was mainly formed together with some other products. Our idea was that avoiding water, avoiding aqueous conditions can be a key to obtain these compounds in solution. And indeed, when we can switch to terbutyl nitrite in the presence of catalytic amount of acetic acid, the compound 2 was obtained in solution, and we managed to characterize it with NMR spectroscopy. Unfortunately, this solution is quite unstable and decomposes significantly upon keeping overnight, even in a refrigerator. Therefore, it should be used immediately into further transformation. And that's what we have done. We have introduced this compound into reaction with electron pair alkenes. And the method worked well. The corresponding pyrazoles were formed from terminal alkenes bearing and electron withdrawing groups. As a set of pyrazoles was obtained. Obviously, the method didn't work with non-activated alkene bearing this heteromoiety. And somewhat surprisingly, the method didn't work with non-terminal alkenes having additional substituent at this position. Even with methyl group, the method did not work. We believe that this is due to steric reasons. Of course, at the moment, the scope of this reaction is not studied to a full extent, and we expect to do that in the nearest future. But for now, I would like to switch to another part of our work, which is related to the synthesis and physicochemical properties of heterocyclic amines bearing the dimethyl phosphinoxide moiety. And we have aimed at preparation of most azitidine, pyrrolidine, and piperidine derivatives, as well as some other compounds, and used a bunch of methods to achieve this. For example, for the preparation of alpha substituted heterocyclic derivatives bearing the vinyl phosphinoxide moiety at alpha position to the hetero atom, we have used a modified Kabachi-Fields reaction involving cyclic amines and the dimethyl phosphinoxide, sorry, in the presence of Lewis acid. And the method worked pretty well. The compounds were obtained with in moderate to good yields on large scale, so that multi-gram preparation of all these compounds became possible. For the synthesis of beta substituted pyrrolidine derivative, we envisaged 3+2 cycloaddition of the corresponding phosphonate of the phosphinoxide 7 bearing a vinyl moiety at the alpha position to the phosphorus. This compound was easily obtained on a large scale by phosphorylation of the corresponding unsaturated bromide, and it underwent the 3+2 cycloaddition smoothly. For that, the pyrrolidine was obtained with high efficiency. When for the pyrrolidines bearing the substituents at the alpha position, like with this compound, for example, this compound, we have designed another sequence commencing from the corresponding beta pyrrolidones protected. We have transformed them in the corresponding vinyl triflates and then subjected to the phosphorylation upon palladium catalyzed conditions. And this method worked well. And then after reduction of the double bond, the corresponding saturated heterocyclic compounds were obtained with high efficiency. Moreover, we applied the same method for the synthesis of these very interesting proline derivatives bearing the dimethyl oxide moiety. What is interesting here that the reduction step was completely diestereoselective, and the corresponding products were obtained as cis isomers with high efficiency. For the preparation of azitidine derivative, we have used simple nucleophilic substitution reaction, since this unit is not prone to elimination, not such prone to elimination reaction as its homologs. And indeed, compound 22 was obtained, albeit in moderate yield, but on large scale. After the protection, we obtained the corresponding azitidine with high efficiency. For the synthesis of beta and gamma substituted piperidine derivatives, we have used the method that was described recently by another group, namely hydrogenation of pyridine derivatives. So in this case, the known method was applied. Finally, we have also prepared the dimethylphosphine substituted, oxide substituted morpholine derivative. In this case, pretty standard reaction sequence for the synthesis of morpholines was used, including the ring opening of the corresponding epoxide, then reaction with chloride, nucleophilic cyclization, reduction, and removal of the protecting group, which finally afforded the target morpholine in good yield, overall yield. The key point of this synthesis was preparation of this very interesting epoxide bearing the pyrimethyl group. This building block was obtained in only 2 steps from commercially available reagents, and it is a very interesting compound for further studies, for further transformations. Only 2 heavy atoms in the main chain, and we have obtained it on multi-gram scale, so it is easily available now. At the final part of this study, we have evaluated potential of our building blocks for their application in early drug discovery programs. We done that by measuring their physicochemical parameters, as well as generating some virtual libraries and evaluating their lead likeness using Adam Nelson's Llama tool. For more details, please refer to this citation, to this Eurojob paper. But I will show some results on this slide. I have shown some results on this slide. So as you can see, the pyrimethyl unit indeed improves the compounds hydrophilicity significantly, at least at about 1.5 points, which is more than the corresponding sulfur-containing groups. So the corresponding dimethylphosphine oxides are more hydrophilic than sulfones or sulfonamides. Meanwhile, the pKa is changed not so drastically as with sulfur-containing groups. So the pKa of the corresponding amines, although it is reduced considerably, it is not so much as in the case of corresponding sulfur-containing analogs. To conclude, I would like to show you all the interesting structures that were obtained or can be obtained as a result of this work, including these pyrazole derivatives, and we planning to extend the study of reactivity of this corresponding pyrimethyl substituted diazole in the nearest future, and also these saturated heterocycles, including these interesting proline derivatives and many other compounds that can be very interesting to introduce the 3-alkyl phosphine oxide moiety into the compounds of interest in drug discovery programs, and I'm sure that this will happen in the nearest future. If you are interested in the results of this work, it was published in a special issue in European Journal of Organic Chemistry dedicated to celebration of 30 years of enamine, and there are also much more interesting results, many more interesting results in this special issue, so please read it if you're interested in it. And finally, I would like to draw your attention to supporting Ukraine, which is very necessary because although Ukraine stands, its support from international community is very much appreciated and very much needed. Just yesterday, we have 2 alerts because of missile launches from Russians. And I'm afraid what will be happening when they will try to celebrate, in quotes, our Independence Day, which is quite soon. So please read our publications where we describe the problems that the Ukrainian scientific community faced. We have been writing a lot about that. For example, this publication is a CS Medicinal Chemistry Letters, where we describe the struggles of the first months we have faced at Inamine. And just recently, we have submitted another paper to PNAS, where we discuss our thoughts on rebuilding Ukrainian science after Ukraine's wins in this war. I have been posting a lot of this on socials. If you are interested in this, please subscribe to my socials and read about Ukrainian-Russian war, and also about our scientific publications. And if you have any questions about the chemistry described in this work, also please contact me by any of the indicated means. Finally, I would like to draw your attention to this site, War Ukraine Way, which describes many opportunities to support and donate to Ukraine. There are local organizations that are verified, and you can donate to them to be sure that your money will go to Ukrainians directly and will support them directly without some international intermediate organization. Again, if you have any question, contact me by the shown contacts. And I would like to thank you very much for your kind attention. Thank you.